In the same way that we have different units for distance, for mass, for length, we have different units to express amount of solute in a solution. So I'm going over three different units to express amount of solute in a solution, and those are units for concentration. So the first one here, it's molarity, and for molarity we use capital letter M. The molarity of a solution is telling you how much solute you have in the unit mole per liter of that solution. So how many moles of your solute you have in every liter of the solution. Okay? That's the molarity. So I have here the molar mass for sodium chloride because that is relevant. If you want to prepare a molar a solution with a molar concentration that is equal to 1, right? A molar concentration equal to 1 means that you have 1 mole in every liter. 1 mole divided by 1 liter, that gives you 1, which is the molar concentration in this specific solution. So if you have a concentration that is equal to 1 molar, what you need is 1 mole of sodium chloride, and 1 mole of sodium chloride is given by the molar mass of sodium chloride. So 58.44 grams per mole is the molar mass, and that is giving you how many grams of sodium chloride in every mole. And if you want to prepare a solution that is 1 molar, you need 58.44 grams in 1 liter as your total volume for the solution. So that is just one example, but you can calculate any concentration, okay? Any concentration, not just 1 molar. But if you want to prepare a solution that is 1 molar, what you need is the mass for 1 mole of the solute in 1 liter of your solution. So I have here an example to calculate the concentration for a solution. I have amount of moles for sodium chloride, 3.50 moles, and you have a total volume for your solution which is equal to 2 liters. In order for you to calculate a molar concentration, what you have to do is divide the number of moles of your solute per the volume, okay, in liters. So if you have 3.50 moles of sodium chloride divided by your total volume of 2 liters, that will give you the molar concentration for this specific solution. So what you're trying to calculate here is the molarity, and you're given amount of solute in units of moles, and you have a total volume for your solution in units of liters, which is what you need to calculate your molar concentration. Amount of solute per liter of solution, and the amount of solute is in moles. So when you divide 3.50 divided by 2, that will give you units of moles per liter, and you should get a number that is equal to that. That should be your answer. So in this problem here, sodium chloride is the solute and the water is the solvent. So what I have here is a couple of problems or examples where you are given a piece of information and you're calculating something else using the information that is provided. So for the first problem here, you're trying to determine a mass of sodium chloride, and you're given a volume and a concentration. So your equation for molarity, whenever you have a problem, you should start by writing down the formula for your concentration. And here you're given a concentration, that's a capital letter M, that's molarity. So you have a concentration there, and you have a concentration here, and you have a concentration down here. So I'm starting all of my problems by writing my equation for molarity. Molarity is moles per liter. Okay? So I have a concentration and a volume. So out of the three things that I have in my equation, I'm given two of them. I'm given a volume right here, 0.5 liters, I have that one. And I'm given here a concentration, 0.15, which is the number that you need right there. What you're trying to calculate is grams of sodium chloride. Grams of sodium chloride is the amount of solute, but in units of grams. So you can use your equation right here with the two given amounts to find out the third one, the one that you don't have. You have molarity, you have volume, so you can actually use these two to find out number of moles. The number of moles that you're finding, it's moles of your solute, because molarity, it's moles of solute per liter of your solution. So you can solve this equation to get your moles of the solute, which I did, and I have that number right there. And now the amount of solute that you need to calculate is not moles, it's grams of sodium chloride. So to go from moles, which is what you have, to grams, you just use the molar mass. The number of moles times the molar mass will give you the grams that you're trying to find. So you have a concentration and a volume, and with that you can calculate moles. And you can solve this equation to get moles, because moles will be your molarity times your liters. So molarity is 0.15, and your volume in liters is 0.5. And that's how I got my 0.075 moles of NaCl. And then what you want to calculate, it's grams, so you have to do an additional step to get the amount of solute in units of grams. Every mole of sodium chloride has a mass equal to 58.44 grams, and that's how I got that number. So this is what your problem is giving you and what you're calculating. The problem is asking you to find out, okay, if you want to prepare a solution that is 0.15 molar sodium chloride, and the total volume for your solution is 0.5, how much solute do you need, okay, in a volume that is 0.5 that is going to give you a concentration equal to 0.15? So that's what you just calculated here. If you add 4.38 grams of sodium chloride and you dissolve those 4.38 grams of sodium chloride to a total volume that is equal to 0.5 liters, you're going to get a solution that is 0.15 molar of sodium chloride of your solute. Now the second one right here, let's see what we have. We have a concentration, we have a number of moles, and you're trying to calculate a volume of your solution. So what you want, it's a volume of this solution that is 12 molar HCl that contains this amount of moles of HCl. So again, I have my concentration equation right here. Molarity is moles per liter. You have a molarity, which is a number right there, and you have a number of moles right here. And you're trying to find out a volume. The volume that you find out using your molar concentration, it's a volume in units of liters, because molarity is moles per liter. Okay? This solution here that it's 12 molar, it means that you have 12 molar, it's 12 moles of HCl, your solute, in 1 liter of your solution. 12 moles over 1 liter, that gives you 12 molar. Okay? So now you're trying to find out, okay, instead of in 1 liter, you know, in 1 liter you have 12 moles of HCl. You want to know, okay, instead of having 12 moles in 1 liter, I want to know the volume of that solution that will contain only 0.425 moles of HCl. So I'm solving my equation here for volume, because that's what you're trying to calculate, volume. So liters will be moles over molarity. And your moles, it's 4.25 mole of HCl, and the molarity it's 12.0. So molarity right there, it's moles over liters, so your moles are canceling out. There are several ways of solving these problems, but I will show you two different ones. And the same thing you can apply to this one here. So 4.25 moles divided by 12, that gives you this number, 0.0354 liters. And you're trying to calculate a volume that is milliliters, so that will be your liters times 1,000, and that's how I got my 35.4 right there. This here, 12 molar, means that you have 12.0 moles of HCl in 1 liter of your solution. So your molarity, it's a conversion factor. Actually, we use molarity in this one as a conversion factor also. It's just that I didn't show you this other way of doing the same problem. So if you're given this number of moles, 4.25 mole of HCl. Look, if you use your molarity as a conversion factor, that will be 1 liter over. Your moles are canceling out with moles, and you're going to get exactly the same number. 35.4 milliliters. So what you're calculating here, look, in 1 liter of this solution that is 12 molar, you have 12 moles of HCl. So now you're calculating in which volume you have 0.425 moles of HCl. If in 1 liter you have 12 moles of HCl, in 35.4 milliliters, you have 0.425 moles of HCl. So this is just solving your equation for the missing part, and you're missing a volume. That's what you're trying to calculate. So you're solving your equation for your 3 things here to get the third one, because you're given 2 right there. You're given the moles and you're given the concentration. So with moles and concentration, you can find the liters. Then the calculation that I wrote down here is exactly the same calculation. It's just that you're using your molarity as a conversion factor. 12 molars means that in every liter of that solution, you have 12 moles of HCl. If you have 12 moles of HCl over 1 liter, that gives you 12 molar. So it's the same thing. Now, in the last problem that I have right here, let's see what you have. You have a volume and you have a concentration, and you're trying to find out the number of moles. Okay? So you're using, in your equation, you have molarity, you have that number, you have your volume in liters right there, and you're just trying to solve for the moles. So I'm not going to solve this one because this is easy. There's no unit conversion, there's nothing. Out of the 3, you're given 2, concentration and volume, so you can calculate the moles of your solid, which is going to be sugar in this case. So just solving this equation for moles, molarity times liters. Okay? So you have your 2 numbers, and you can calculate how many moles you need, and that should be your answer, something close to 1.2. And this one, we did something very similar, so you can solve that one also. Again, you have a molarity right there. You have molarity for a solution of sodium chloride, 0.8 molar, and you have a volume, and you're trying to find out amount of solute. So molarity is amount of solute in moles per liter of your solution. So you can use your molarity and your volume, two things, in your equation of molarity to find out the number of moles of sodium chloride, and then you can convert those moles to grams using the molar mass of sodium chloride, which you already have. Second unit for concentration, and we're doing 3, so this is the second one. The first one is molarity, but I spend a lot of time with molarity because that's the one that we use in the lab more often. So molarity, besides you knowing how to prepare a solution with a specific concentration, you need to know how to use molarity as a conversion factor. If you're given molarity and volume, you can calculate moles, or if you're given molarity and moles, you can calculate volume. Those are the problems that we went over just now. So molality, it's something similar to molarity, but in here we're not giving your concentration in units of moles per liter. Concentration, or molal concentration, lowercase m, it's the moles of your solute in every kilogram of the solvent. So I have just one problem here where you have to calculate the molality of your solution. You have 17.2 grams of ethylene glycol, which is your solute, and those the grams of ethylene glycol are dissolved in 0.5 kilograms of the water. Now, if you're not sure which one is your solute, which one is your solvent it's always in a higher amount than the solute. You're using the solvent to dissolve a solute, so your solvent should be in a higher amount. You should have more solvent than solute, always. So you can compare your amount, 17.2 grams versus 500 grams for the water. That's 0.5, but that's 0.5 kilograms, which means that if you want to compare, you need to have the same units. So 17.2 grams versus 500 grams. So 500 grams should correspond to an amount of solvent because it's a bigger number. So to calculate your molality, your molal concentration, lowercase m, you need the moles of your solute, which is your ethylene glycol, but your amount of solute is given in grams, so we have to convert the grams to moles first. That's why you're given the molar mass right there. So to convert grams to moles, you're dividing by the molar mass. And I have a number of moles that is 0.277, and I'm doing 3 significant figures, so that's mole of C2, H6O2, which is ethylene glycol, and that's your solute. So now molality will be your moles over your 0.5 kilograms of water. And the molality for that solution is equal to 0.554, which is the number that I had right there. So in the same way that we use molarity as a conversion factor, if you're given volume and concentration, you can find moles. In this case here, if you're given volume, kilograms of your solvent or amount of solvent in units of mass and the concentration, you can use those two to find out the number of moles. Always, if you have an equation with 3, You have molarity, moles, kilograms. If you're given 2 out of the 3, you can use those 2 to find out the third one. So if you have a problem where you're given kilograms of solvent or any amount of solvent in units of mass and molality, you can find out the moles. Or if you're given the moles and the molality, you can use those 2, or amount of solute in any unit. You can use those 2 to find out the solvent, the amount of solvent. And the third one, it's unit for concentration. The third one, it's parts by mass. It will be mass over mass. Mass of your solute over mass of your solution. The total mass of your solution. And the solution, for in the beginning of this topic, a solution, it's a solute plus a solvent. You have those 2 components added together. So for the mass of the solution right here, you need the mass of your solute plus the mass of the solvent. Now, parts by mass, this part here, it's always the same. Mass of your solute over mass of your solution. And mass can be any unit of mass as long as you have the same unit for both of them. Percent by mass, you will have mass of your solute over mass of your solution times 10 to the second. This part here is the same. Your exponent right there is different depending on what unit are you trying to get. If you're trying to get concentration of a solution in parts per million, this here will be 10 to the 6. If you're trying to get concentration of a solution in parts per billion, that X right there will be 9. So mass of solute over mass of your solution times 10 to the 6 will give you parts per million. Mass of the solute over mass of your solution times 10 to the 9 will give you parts per million. And then the one that we're doing right here, if you have mass of your solute over mass of the solution times 10 to the second, which is 100, that will give you the percent by mass for your solution. So in your problem, you're trying to find out percent by mass. So I'm going to write down my equation, mass of solute over mass of the solution times 10 to the second, because it's parts by percent by mass, which is 10 to the second. So the mass of the solute you have right here, 25.5 grams of sodium chloride dissolved in 425 grams of water. Just ignore the dog, she's super bored. So mass of your solution right here, it's the mass of your solute plus the mass of the solvent. So for your solute, you have 25.5 grams of sodium chloride, and the solvent is the water, and for that one you have 425 grams of water. So to get the mass of your solution, you need to add those two together. 25.5 plus 425, that's 450.5. Ten to the second. So 25.5 divided by 450.5 times 10 to the second. 66%. So if you have 25.5 grams of sodium chloride dissolved in 425 grams of the water, the total mass of your solution will be 25.5 grams plus 425 grams of the solvent. That's the total mass of your solution, what I'm showing you right here. And then to get the percent, you divide the mass of your solute divided by the mass of your solution, which is that number, times 10 to the second, and that will give you the percent by mass for this specific solution. And one more thing here. A dilution, it's a solution that we prepare based on a solution that we already have. So we have a solution and we know the concentration from that solution. And then we can prepare a diluted solution taking a volume, like a volume from that solution that we know the concentration. And then we dilute that volume to a new volume and we get a new concentration. That new concentration, it's a lower concentration because you're diluting your solution. Now, important things about dilutions. You have a solution that contains the same solute. It's a solution that is already prepared. You have your solute there and you're preparing a dilution. So in your dilution, you still have the same solute. Now, we have an equation that allows you to calculate like anything. If you're given 3 out of the 4, you can get the 4th one. Usually we use this solution here to determine the concentration of the diluted solution or to determine how much we need from the original solution to prepare a new solution with a specific concentration and a specific total volume. So I have here my equation. What I have on the left side of your equal sign is your initial concentration. C is for concentration, initial volume. And then on the right side, I have the final or the new, what you're preparing. A diluted concentration and a final volume. Now, concentration for your initial solution, it's always higher than the concentration that you have for the final. You're preparing a dilution, so your final concentration should be smaller than the initial concentration. Your final volume needs to be bigger than your initial volume. Your initial volume is how much you're taking from that original solution to prepare your dilution. So if you're diluting something to a bigger volume. So your final volume should be a bigger number than your initial volume. So I have here, your problem is just that part. I did my drawing so you can see how we do this, and you have done this in the lab already. So you have diluting 50 to 500. So you have 2 volumes in your equation and you're given 2 volumes in your problem. You need to be able to identify which one is your initial volume and which one is your final volume. So if you remember this here, your final volume is always higher than your initial, which means that your 500 should be your volume 2. And then your 50 should be your volume 1. So you're taking 50 milliliters from this solution. And that concentration that you have with your initial volume, that should be your initial concentration. And what you're trying to find out is your final concentration, or C2. So that's what I have here. I have my solution, which is 1.50 molar HCl. I'm taking 50 milliliters from that one, and I'm diluting those 50 all the way to 500. So when you're diluting your 50 to 500, now you're going to have a new concentration. So we can solve your equation for C2 because you have three things that are given. You have your initial volume, your final volume, and you have your initial concentration. So I'm going to solve my problem for C2. And that will be C1 times V1 divided by V2. Before you calculate your number, if you're calculating a final concentration, your C2, you have that your final concentration, C2, has to be smaller than C1. So before you get your final number, you should be aware that the concentration that you're trying to get here should give you a number that is smaller than 1.5. A dilution, your final concentration will always be smaller than the initial concentration. So if you do C1, 1.50 times your V1, which is your 50, divided by 500, that will give you 0.150. Okay? And that's molar concentration because your volumes are canceling out. So this is another thing. Whenever you're using your equation for dilutions, if you have two volumes, you don't need to convert your volume to liters because your milliliters, they cancel out. If you choose to convert your volumes to liters, you still get the final number. It's going to be the same. Okay? That should be your concentration for the diluted solution. And there's a problem for you to work. You have grams of your solute, you have a total volume for your solution, and you need to calculate a molarity. So to calculate molarity, you need moles of your solute, which is your KBR, divided by your volume for the solution in liters. That's how you get the molarity. And then interesting is that you need to find out also the mass percent or percent by mass for your solution. So that's how you calculate your percent. Now, you are not given a mass for the solvent, and you do have the mass of your solute. So that part you have that you can use right there. But in the previous problem, you calculated the mass of your solution, adding the mass of your solute and the mass of the solvent. But in this problem, you're not given the mass of the solvent, so you cannot do the same thing to calculate the mass of your solution. To get the mass of your solution in this problem, you have the total volume for your solution times the density for your solution, and that will give you the grams for your solution. So it's a similar problem with the modification, and the modification is how you're getting the mass of your solution. In the previous problem, since you were given the mass of your solute and the mass of your solvent, you calculated the mass of your solution just by adding those two together. But in this one, you don't have a mass of the solvent. What you're given is a total volume of your solution and the density for the solution. Since you have the total volume and the density, when you multiply total volume times density, which is grams per milliliter, your milliliters are canceling out from here with the milliliters from the density value, and you're getting a number that it's in grams. So for the percentage, you should get a number that is close to 9.3%. That should be your answer. And for the molarity should be something close to 0.9, something like that. That should be your answer.